So when we first start learning about angle measures, we use 360 degrees as our starting point, where 360 degrees actually represents a full circle. And so we do 360 degrees is a full circle. So breaking that circle up into 360 parts allows us to know what 1 degree is. And so 1 degree might be for instance, like that. Obviously, that's exaggerated a little bit, but there are 360 degrees that make up a full circle. 360 is actually a relatively arbitrary term. It allows us, when we do it, it gives us 4 right angles inside the circle, all of which are 90-degree angles. And those right angles are very important to us, and we learned a lot about it. But the question is, why not 100 degrees? Maybe 100 degrees would have made more sense. If we had done that, then all they'd be doing the exact same thing, except that each of the angles now represents, instead of 1/360th of a circle, it would represent 1/100th of a circle. So your degree now would maybe be a little bit bigger, being 1/100th of a circle instead of 1/360th of a circle. And then not only that, instead of having 90-degree angles being right angles, you would have 25-degree angles being right angles. You'd have 4 25-degree angles that add up to 100. So what we see by looking at this is that 360 is actually arbitrary. So radians, and instead of using this idea of a number like 360 degrees, says, well, maybe it makes more sense for our purposes to consider what we call the unit circle, which is a circle of radius 1. And a circle of radius 1 has a circumference which is equal to 2 pi r, which is 2 pi. And so instead of saying a circle is 360 degrees or a circle is 100 degrees, we say a circle is 2 pi radians. So when you're talking about radians, we say 2 pi equals a circle. So pi equals half a circle. Half a circle, by the way, is just an angle that is a straight angle, which is the same as a 180-degree angle. If I wanted to know what a quarter circle is, which is a right angle, I divide 2 pi over 4, which turns out to be pi over 2. So now pi over 2 is our right angle. So pi over 2, 8 radians, gives us a right angle. So our conversion is any one of these. 2 pi equals the circle, or 360. Pi equals 180, or pi over 2 equals 90, however you want to think about it. So that allows us to know a method for converting degrees to radians. If you have a certain number of degrees, x degrees, well, if I multiply, because what I want to think about is, well, how much out of 180 is that degree? And then I want to multiply that by pi, so all I need to do is multiply by pi over 180. So x degrees is equal to x times pi over 180 radians. So the key is multiply by pi over 180. So for instance, if you've got, as we've just talked about, if you've got a 90-degree angle and you want to convert it to radians, you multiply by pi over 180 degrees. 90 goes into 180 2 times, and so it's pi over 2. If you want to go the other direction, you do the same thing we always do when we go the other direction, and that is we multiply by the reciprocal. So x radians, or we could say y radians, is equal to x times, or y, I mean, times 180 over pi degrees. So for instance, if I have pi over 3, if I want to convert that to degrees, I multiply that times 180 over pi, and that gives me 60, 180 over 3 degrees. So pi over 3 radians is equal to 60 degrees. And that makes sense because pi is equal to 180. So 1/3 of pi is equal to 1/3 of 180, which is 60 degrees. So degrees to radians, you multiply by pi over 180. Radians to degrees, you multiply by 180 over pi.